So section 4.1, rational functions and asymptotes. So the rational function, which in fact they said it's r of x always, which is the same thing, but just to know it's a rational function. And that's how it looks like, the rational function. That means there is polynomial on the top and the polynomial on the bottom. And always the polynomial on the bottom is not equal to the 0 because you can't divide by the 0. Like a simple example about that, if you have r of x equal x squared plus 1 over 2x cubed. This is a rational function. We're not going to go in details now because our goal in this section is how to find the asymptotes. Then next section, we're going to learn how to graph it. So the asymptotes, the first asymptote is the vertical asymptotes. And it's a vertical dashed line. That means the function is going to be undefined on this asymptote. So when you graph it, for example here, like it's going to be a vertical dashed line. Like for example, if you have an asymptote here at this point, the function is never going to cross this asymptote. It's going to be like this, or it's going to be the function like this, or the opposite, never going to cross this vertical dash line. So this is a vertical asymptote. How are we going to find this asymptote? By the set the denominator equal to the 0 and solve it. Just like this. You're going to take the denominator and equal to 0 and solve it, and the result is going to be the vertical asymptote. We're going to do an example. The second asymptote is the horizontal asymptote. The horizontal asymptote, we have 2 points to find the horizontal asymptote. It depends about the degree on the top and the degree of the polynomial on the top and the degree of the polynomial on the bottom. So if the degree on the top, I meant the polynomial on the top, less than the degree of the polynomial on the bottom. That means n here, for example, is 2, and n here, for example, is a 3. If the degree on the top less than the degree on the bottom, that means the horizontal asymptote y equals 0. Just like this. If you see the exponents on the top less than the exponents on the bottom, I'm talking about the highest exponents on the top less than the highest exponent on the bottom. So the horizontal asymptote y equals 0. The second thing, if the degree on the top equal to the bottom, that means the highest exponents on the top equal to the highest exponents on the bottom. In this case, the horizontal asymptote is going to be y equal the leading coefficient on the top over the leading coefficient on the bottom. This is for the horizontal asymptote. But there is a third one which is different. Now, if the degree on the top is greater than the degree on the bottom, in this case, no horizontal asymptote. Here, we're going to get another asymptote. It's called slant asymptote. The degree on the top greater than the degree on the bottom. You're going to get a slant asymptote. How to find the slant asymptote? You're going to just use the long division and the quotient, which is the result of this long division, is going to be the slant asymptote. You're just going to type y equal q of x. Like you're going to type here y as a slant asymptote equal how much you're going to get as a quotient. You're going to type it as a slant asymptote. So that's how we're going to find the slant asymptote. I need you to write down these notes because we're going to do examples and you will see the difference about how to find each asymptote. Let's start with example 4. We have f of x. The function is f of x equal 1 over x squared. 1 over x squared. Our goal is to find the vertical asymptote and the horizontal asymptote. To find the vertical asymptote, we're just gonna set the denominator equal to the 0 and solve it. So let's set the denominator, which is, so the vertical asymptote is going to be set the denominator equal to the 0. Then I'm going to solve this one by taking square root for both sides. So x is going to be equal to 0. That's mean when you graph this one, this is x and here's y. At x equals 0, which is this one, there is a vertical asymptote. That means there is a vertical dashed line at this point. Vertical dashed line at this point, the function never going to cross it. The function, when you graph it, never going to cross at x equals 0, which is the same thing, the y coordinate. So this is the first vertical asymptote. Now to find the horizontal asymptote, we're going to check the degree on the top and the degree on the bottom. The degree on the top is 0 because x to the power 0. That means the degree on the top is 0. The degree on the bottom is 2. That's mean 0 less than 2. In this case, if the degree on the top less than the degree on the bottom, that means the horizontal asymptote y equal 0. So you're just gonna say the horizontal asymptote y equals 0. So here is the horizontal asymptote y equals 0, and here is the vertical asymptote. So the horizontal asymptote when y equals 0. So where is y equals 0? That's mean here. There is another vertical dashed line, y equals 0, y equal 1, y equal 2, y equal 3, and keep going. But now we have y equals 0, so here is the horizontal asymptote. That's mean the function sometimes going to cross the horizontal asymptote, but never going to cross the vertical asymptote. So this is for the first example. So we're just gonna type x equals 0, comma, and y equal 0. That's it for this example. Let's check the second one. Example 5. We gotta do the same steps. Find the vertical and horizontal asymptote. So our function now, f of x equal 4 over x minus 7 cubed. 4 over x minus 7 cubed. So now let's do the same thing. Find the asymptotes. The vertical asymptote, we're gonna set the denominator equals 0. So the vertical asymptote, we're gonna say the denominator, which is x minus 7 cubed equals 0. Now, how I'm gonna solve this one? I'm going to take the cubic root for both sides. The cubic root of x minus 7 cubed and the cubic root of 0. Then cancel here. That means x minus 7 is going to be equal 0. In this case, we're going to solve this one. X is going to be equal 7. So this is the vertical asymptote. That means when you graph it, x equals 7, 1, 2, 3, 4, 5, 6, 7. At this point, when x equals 7, there is a vertical dashed line. The function never going to cross this vertical dashed line. This is x equals 7, the vertical asymptote. Now to find the horizontal asymptote, we're going to check the exponents. The exponents on the top here is 0. The exponent on the bottom is x cubed. X cubed, that's mean 3. So 0 less than 3. In this case, when the top less than the bottom, that's mean the horizontal asymptote y equals 0. So we have a horizontal asymptote here when y equals 0. Y equals 0. This is the horizontal asymptote, and here is the vertical asymptote. So we're going to type here y equals 7, or x equals 7, comma, y equals 0. That's it for this example. Now, let's check the next one, example 6. We're going to do exactly the same thing. The function is f of x equal 5. Oh no, example 6, 1 plus x. 1 minus x. And we need to find the vertical asymptote and the horizontal asymptote. How are we going to do that? The vertical asymptote, we're just going to set the denominator equals 0, which is mean 1 minus x equals 0. Now solve this one. We're going to add x to the both sides. So it's going to be 1 equal x. That's mean x equal 1, which is the same thing. So on this graph, for this function, we have a vertical asymptote when x equal 1. Here's x equal 1. We have a vertical asymptote. That means the function never going to cross this dashed line. To find the horizontal asymptote, now let's check the degree on the top and the degree on the bottom. The degree here, be careful, the degree, the degree here is 1, and the degree here is also 1. So in this case, the degree on the top, 1 equal 1. So we're gonna go to the next one, which is if the degree on the top equal to the bottom, horizontal asymptote is going to be y equal the leading coefficient on the top and the leading coefficient on the bottom. So we're gonna say y equal the leading coefficient. This is the degree. The leading coefficient, the number here, not the one here, which is also 1. The leading coefficient on the bottom, which is here is the x, the highest exponent here, the leading coefficient is -1. That's mean y equal -1. So here is the horizontal asymptote. That's mean y equal -1. You see here is -1. That's mean here is -2. So there is a dashed line here at this point, y equal -1. This is the horizontal asymptote. So let's find the vertical and horizontal asymptote for this graph. So the vertical asymptote is we're going to let the denominator equal 0. That means 5 plus 7x equals 0. And now we need to solve this one for x. So we're going to say -5 from both sides. So it's going to be 7x equal -5. Then we're going to divide both sides by 7. That's mean x is going to be equal -5 over 7. So this is the vertical asymptote. To find the horizontal asymptote, we're going to check the exponents. The exponents on the top 1. The exponent on the bottom is 1. 1 equal 1. That's mean our horizontal asymptote is y equal the leading coefficient on the top, which is -2, the leading coefficient on the bottom, which is 7. So this is our horizontal asymptote for this rational function. So we're going to type here x equal fraction, which is -5/7, and comma y equal another fraction, which is -2/7. Next one, find all vertical and horizontal asymptote. So they just ask you about find the vertical and horizontal asymptote. So let's check example 8. They didn't ask you about the third asymptote, the slant asymptote. So f of x here on this function is x cubed over x squared minus 1. So let's find the vertical asymptote. To find the vertical asymptote, we're going to set the denominator equal to the 0. Then I need to look to this side. I'm going to factor this side by using difference between two squares. Or if you want to move the 1, it's fine, but you have to take the square root for both sides. X minus plus 1 and 1. Then you're going to set each one equal to 0. X minus 1 equals 0. Or x plus 1 equals 0. Solve this one, you're going to add 1. So x is going to be equal 1. And here minus 1 from both sides. So x is going to be equal -1. That means we have two vertical asymptotes. So when you graph this function, we have an asymptote here when x equal 1. And we have an asymptote here when x equal -1. Two vertical asymptote here, x equal -1 and x equal 1. That means the function exists here and between these two vertical asymptotes and here. To find the horizontal asymptote, the exponent here is a 3. The exponent here is 2. And the 3 greater than 2, that means in this case, there is no horizontal asymptote because this is the third one. If the degree on the top greater than the bottom, no horizontal asymptote. So just gonna say no horizontal asymptote. We have another asymptote is the slant asymptote, and we're gonna learn how to find the slant asymptote next section. You just have to divide x cubed divide by x squared minus 1. How are we gonna do that? Using the long division. We can do that now to practice about the slant asymptote. But the result for this one is going to be just the vertical asymptote x equal -1 and x equal 1. Because that's the only thing they ask you for this example. But the degree on the top is greater than the degree on the bottom. That means there is a slant asymptote, for example, 8. There's a slant asymptote on this one. So this is example 10. Let's find the vertical asymptote. We're going to set the denominator equals 0. That's mean x squared plus x plus 5 is going to be equal 0. If you look to this one, you can't factor it by using the AC method or by the regular methods because you have to use the quadratic formula because 5 is 1 times 5, and you can't find 1. In this case, there is no vertical asymptote because you're going to use the quadratic formula, and the result is going to be a complex number. So the result after using quadratic formula is going to be complex number. That's why you're going to say no vertical asymptote. To find the horizontal asymptote, the exponent here on the top is 2, and the exponent on the bottom is equal to, and these are equal. 2 equal 2. So y is going to be equal the coefficient on the top, which is the leading coefficient here is -2. The leading coefficient on the bottom, which is 1. That means the horizontal asymptote y equal -2. This is the horizontal asymptote. No vertical asymptote. So on this example, we're just going to type y equal -2. Y equal -2. Example 11, we're going to do exactly the same thing to find the vertical asymptote and horizontal asymptote. So if you look here, example 11, which is f of x equal 6x squared plus x minus 8 over x squared plus 1. To find the vertical asymptote, we're going to set the denominator equals 0, which is x squared plus 1 equals 0. How are we going to solve this one? We can't use the difference between two squares because it's a plus. So I need to move the 1 to the other side. That means x squared is going to be equal to -1. Then I'm taking the square root for both sides. So x is going to be plus or minus -1 goes out as an I. So plus or minus I. This is a complex number. So we can't grab the complex number. So we're going to say no vertical asymptote. To find the horizontal asymptote, the exponent on the top is 2. The exponent on the bottom is 2. 2 equal 2. That means the horizontal asymptote, the exponents on the top 2 and on the bottom 2. So y equal the coefficient on the top, which is the leading coefficient is 6, and the leading coefficient is 1. That means y is going to be equal 6. That's it for this example. So on example 11, we're going to say y equals 6. Because the first thing always when you check if you can simplify. So always simplify the function before you finding the vertical asymptote and horizontal asymptote. So f of x on this example is equal x minus 8 over, if you look to the bottom part, you can simplify it by using the difference between two squares, which is you're going to open two parentheses, x 64, which is 8 times 8. You're going to put a plus and minus. Now, if you look here, everything here is similar to this one. So we're just going to cancel it. That means f of x is going to be equal 1 over x plus 8. So now we can find the vertical asymptote and horizontal asymptote for this one. So the vertical asymptote is going to be set the denominator equal to 0. That means x plus 8 equals 0. In this case, x is going to be equal to -8. And the horizontal asymptote, the exponents on the top is 0. The exponents on the bottom is 1. 0 less than 1. That's mean our horizontal asymptote y equal 0. That's it for this example. So we're going to type here x equal -8 and y equal 0. Example 13. Now this is a little bit different. Example 13, 14, and 15. These examples are different. So we're going to do the same thing. We're going to simplify the function. So f of x equal. On the top part is minus between two squares, difference between two squares. So I'm going to open two parentheses. I'm going to say x, 6, 6, and 1 plus, 1 minus. On the bottom part, we're going to open another two parentheses because we can factor this one by x, 30, which is 5 times 6. And I need to get -11. So minus. It's going to be -6x and -5x added is going to be -11x. So now, sorry, I can simplify it by cancel this one with this one. That's mean f of x is going to be equal x plus 6 and x minus 5. Now we're going to find the vertical and horizontal asymptote for this example. The vertical asymptote is going to be set the denominator equals 0. That's mean x minus 5 equals 0. In this case, x equals 5. The horizontal asymptote is going to be the exponents on the top is 1. The exponents on the bottom is 1. 1 and 1. That's mean 1 equal 1. So the horizontal asymptote is going to be y equal. The coefficient on the top here, the coefficient was 1. The coefficient on the bottom is 1. That means the horizontal asymptote y equal 1. That's it for this example. Let's check if we can simplify this one. We're going to factor the top and we're going to factor the bottom. So to find a 23. So we're going to say f of x equal. You see, the factoring is really important. So we're going to open two brackets. Sorry, two parentheses. And let's see. 12, I'm going to use 3 times 4. So if I used 4 here, I'm going to use 3 on the other side. So 4x here and the 3x here. Now, 12 also, I'm going to put the 3 here and 4 here. Now let's check here. 4 times 4 is 16. And the 3 times 3 is 9. So 16 minus 9 is going to be 7. So now I need to get positive 7. So what I'm going to do, I'm going to make -9 and positive 16. So now 4x times 4 is going to be 16x. Negative 3 times 3 is going to be negative 9x. Add these together is going to be 7x, which is the middle term. Let's do the same thing here. 4x, put down 4x here, and put down just x here. 15, I'm going to put 5 here and 3 here. 4x times 5 is going to be 20. 3 times x, 3x. And when you add it, it's going to be negative 23x. So I'm going to put minus here and minus here. Now let's check. Is negative 3x and 4x times 5 negative 20x. Add these together is going to be negative 23x. Now check, we have like terms. This parentheses cancel with this one because they are the same. That means alpha of x is going to be equal 3x plus 4 and x minus 5. Now we're going to find the vertical asymptote, which is set the denominator equal to the 0. Solve this one, so x is going to be equal 5. And the horizontal asymptote, the exponent on the top is 1. The exponent on the bottom is 1. So 1 is equal to 1. In this case, y is going to be equal the leading coefficient on the top, which is a 3. The leading coefficient on the bottom is 1. That means y is going to be equal to 3. So this is the horizontal asymptote. Here is the vertical asymptote. This is just to find the asymptotes. So we're going to type here x equal 5 and comma y equal 3. This is example 14. The last example on this section is, we have 2 more. You see now, they're going to ask you to check which one is going to be the right graph by just looking to the asymptotes. So match the rational function with its graph. First of all, the vertical asymptote here is negative 5. Because, for example, 15, it's alpha of x equal 2 over x plus 5. So now let's look the vertical asymptote, which is x plus 5. That means x equal negative 5. Horizontal asymptote is, check the exponents. The exponent here is 0. The exponent here is 1. That means 0 less than 1. So our horizontal asymptote y equals 0. So let's check which one we have these two vertical asymptote, negative 5. So look, here is positive 5. This is positive 5. So we're going to cancel these two. We're not going to choose this one. We're not going to choose this one. Now let's look to this one is also positive 5. All these positive 5. Look, do we have something wrong here? I think, oh, it's x plus 5. So x minus 5. Oh, here. This is negative 5 and this is negative 5. So this is the first one, could be right. And here is the second one because it's negative 5. But now let's look to the horizontal asymptote, y equals 0. If you look to this graph, the horizontal asymptote y equal not 0, equal 1, because here is 1, 2, 3, 4, 5. That means the horizontal asymptote y equal 1. Y equal 1. So here is the horizontal asymptote. So we can't choose this one because we need to get y equals 0. So here's y equals 0, and here's the vertical asymptote y equal, x equal -5. So we're just going to choose this graph. So by just locating the asymptotes, we can figure out which one is the right graph. Next one is example 16, the last one. We're going to do the same thing by locating the horizontal asymptote and vertical asymptote. So the vertical asymptote, x minus 2, that means x is going to be equal to x minus 2 is going to be equal 0. That means x is going to be equal to. This is the first vertical asymptote. And the horizontal asymptote is going to be the exponent. So let's check the exponent on the top, which is 1 and 1. That means 1 equal 1. So our horizontal asymptote is going to be the leading coefficient on the top. I'm going to say -2. Don't forget the negative sign here. And the leading coefficient on the bottom is 1. You can't say -2 and -1 because negative divided by negative is going to be positive. So you're going to put the negative sign on the top or the negative sign on the bottom. You're going to say -2 or -1. That means y is going to be equal to -2. So now let's check which one is going to be the right graph. So if I look to this one, this is 1, 2. So it's +2. The vertical asymptote, which is right, 1, 2. This one is -2. So I'm going to cancel this graph because I'm looking just the vertical asymptote first. This one could be right because here's 1, 2, 3, 4, 5. And this one is -2, just there. So this is wrong. By just locating the vertical asymptote, we cancel 2 graphs. Let's look to the horizontal asymptote, y equal -2. If I look here, the horizontal asymptote y equals 0, because you see the dashed line, it's exactly on the x coordinate. That means y is 0. If you look here, y equal -1, -2. So this one is going to be the right graph. So I'm just going to click here and submit. That's it for this example.